Hello, ladies and gentlemen. My name is Anurag, and you are watching Think World. So, welcome back to my channel. This channel is dedicated to exploring the areas of art and technology. We discuss about programming, we discuss about system architecture, discuss about system designs, and in 2025, I'm also planning to bring more videos on financial education because that is very important, as I discussed in our last video. But anyways, for this video, our main goal is to extend our previous video where we wrote an biosimulation in Python, and we created an organism. Okay. Let me take you to the code now. It was a bear roaming in the forest, and it can eat two berries. Just for a quick recap, I will take just 30 seconds of your time. It's a bear, and it can roam around in the forest, and it can eat multiple berries. So we have two kind of berries: red berry and green berry. Red berry is we are assuming we are making it as a poisonous to him, and green berry as a food. So in the previous code, we have created our bear class. We have created our dot class. It's not dot class is nothing but our food class, and it is taken from Iris famous Iris dataset. It has only for the simplicity, we are taking only sepal length and sepal width as our data features. We give them random coordinates x and y on to create a visualization. We create we find we get the we have functions to get the nearest dot, or maybe you can say that we have a function to get the nearest berry to that bear. Then that bear moves to that nearest berry and eats it, whatever it is. If it is a food, it eats it. If it is a poison, it eats it. For now, but from today, we are going to give this our brainless bear a brain, so that he can think about what to eat. If it's a berry, a food berry, he will eat it. If it's a red berry or poisonous berry, it will not eat it. He will not eat it. Okay. So major chain, I have uploaded this code in my GitHub. You can find it simulation.py, latest simulation.py on my GitHub. So I have made few changes here. So first major change is that we have included this not if this new if conditions is tested. Okay. So why our berry is have an attribute is tested. So initially it is false, but as soon as our beer reaches to that berry, and let's say it just analyze it. If it is a food, it is a poison, we don't know it, but it is just the bear just came to it and analyzed it. So as soon as our bear came to that berry and analyzed it, we make this is tested variable as true. So we are doing this to avoid the infinite loop, because in the function find the nearest dot, if we do not get this is tested, it will fall into a infinite loop, because the nearest dot to the bear is the current berry. So in our brainless bear, what we were doing is that if the bear is going to a red or green dot, it was eating it, and we were removing it from our superset. But now we are not removing it from the superset for the sake of visualization, but keeping it there in the red dot. So if we do not add this variable, our loop will go into infinite loop, because the nearest dot in the superset is itself. So to prevent this, we are doing is tested. So basically it is nothing but basically, if a dot is tested or visited once, it is marked as visited, and it will not be considered in the further iterations. That's what I want to say. Okay, so the next line I have written here is line number 66. Okay, so this is I have imported brain .knn. So if you can see, I have imported brain file, and brain file is nothing but our another Python file, which is including our knn algorithm. So you might be aware that our knn machine learning algorithm is k nearest algorithm, where as it is saying that birds with the similar feather flocks together. So let's say we have 10 red dots and we have 10 green dots, and you get a new dot. You don't know the color as of now, but that new dot is the most of the neighbors for that new dot is green. So by intuition, we can say that that new dot is also green. Okay, getting my point. Otherwise, I will reiterate it. Let's say you have five red dots in a cluster because they are all the poisons, or they belong to a same category. They will be very close to each other on a Cartesian product, or maybe in the 4D 5D planes. Okay, 4D space, sorry, not the plane, 4D 5D space. And you have another cluster with the green dots in 4D 5D planes. Now you got a new dot, and you don't know yet if it is a green, or it is red, or it is a food, or it is poison. You don't know yet. But let's say it is most of the neighbors of that new dot belongs to our green dots, green cluster. So intuitively, we will say that this new dot is also green dot. So this is all about k nearest neighbor algorithm. K is nothing but the number of neighbors we are considering to assign the new dot, assign the new uh, data set a cluster. Okay. So so on the same lines, uh, you might be guessing it as of now that we have to find the distance. So in the 2D points, we can use the simple Euclidean distance in x and y coordinates. The beauty of Euclidean distance is that you can extend it with n number of dimensions. So for now, it is just 2 dimensions. So we will be just differentiating. We will be using the x and y coordinates from uh, our superset. Okay, just let's have me a coffee once. So this function is very similar, very simple. I have given a name to kn. It will get the it will have the two and three um, parameters. One is test berry, which will be coming from our simulation. Test berry is nothing but the bear goes to a dot, it observes it, it takes the sepal width and sepal length and pass it in here functions. Features is nothing but we are opening our forest data files, which looks like this. It is our data set minus the training data set. So what we have done is that, let's say we have 100 data points. So we have divided into 80 and 20 ratio. 80 points are used for training, and 20 points are used for uh, testing. So these 20 points are used in simulation, and 80 points are used for training. So it is what is it doing? That it is getting the difference between the current berry on which the beer is trying to eat, and passing it to its brain, our brain.py. It gets the distance. We sort it based on the distance. This k number is we have given k as 3 because we it is very simple, reasonable data set. So we can give k equal to 3. K is the number of neighbors, and we prefer it to give it as an odd number, so that because even numbers can create race conditions. So our distance list will store all the distances from the current berry, and the whole superset. We get the top, we can we are sorting in here, and we are getting the three closest neighbors for that our test berry. After that, we count it, that in those three neighbors, which is majority of, if the food is majority or the poison is majority. That's why I was saying that k should be in odd number. If, let's say, if you keep your k as a even number, two neighbors might be your food and two neighbors might be your poison. So in that condition, you will be in trouble. You cannot make a you cannot make an non-ambiguous decision. So k is mostly preferred as an odd number. So line number 29 to 32, we are counting the number of food and number of poison. Whatever is more out of three, let's say two. If two is food, we return food. If the number of data points is more for poison, we return poison. So this is our KNN, or we can say our brain file for our bear, and it is being used in our simulation file in the line number 66. Okay, so our find nearest dot function is returning a prediction if it is a food or a poison, along with the nearest dot. Okay. Apart from that, I have not made any major changes. It is just most of the cosmetic changes. I have created this food and poison condition. If it is a food, our prediction is food, and it is actually a food from our training and testing data set. We are getting that if it is, let's say, our bear goes to a berry and it predicts that it's a food. Okay, so we have to go over to Excel file which we have used to spread our berries. We will go to that Excel file and check it if it is actually a food, because we know it. It doesn't know it, but we know it. So if it is actually a food, we increase its height. So not height actually. We increases its size and remove that point from our superset because it ate it. If it is not the case, we set it to beer size to the 5. If it is not a food, certainly it's a poison. So we decrease its size radically and remove that point from our dataset because is ate it. Otherwise, if it is a poison, we do not remove it from our dataset, but it we mark it as a tested true. So next time, if the tested is true, we are not going to consider it is our nearest in the set of our nearest dots. So we are preventing by this condition, we are preventing an infinite loop. Otherwise, we are after that we are just giving the random colors like green for food, orange for food but tested, and red for poison at all. Okay, so now it's time to let's run to our simulation and let's see how our BR is performing. So I'm going to Python simulation. I have increased the frame rates and interval to make it more smooth. So our bear is going to the forest. It's ate the red berries, sorry, red the green berries, and you see you observe that this is an orange berry. That means it is a food, but our bear misclassified because accuracy is not 100% for our KNN algorithm. Our machine learning algorithm does not have the 100% accuracy. So this data point was a food, but it did not eat it. It considered it. Our bear considered it as a poison and avoided it. That's why it's orange. And I don't think our bear is going to eat any poison because it's not misclassifying any poison. And if that was the case, the size of our bear reduces to 5 units. That's a drastic change. So our whole simulation ends here, and we can see that from our previous video, it's not eating our berries randomly. It's going to a nearest berry, giving the sepal width and sepal length and its features, how the color is, how the width, sepal length and sepal width is, sending it to brain and doing some calculations and trying to find out if it is a poison or a food. If it is a food, it will eat it. If it's a poison, it will avoid it. So that's how we can ensure that our beer is long living. So I think that's all for our project. I am not sure that we are going to for this project we are not going to have any more videos. We can end this project here. And if you have any doubt, you can comment. You can DM me on my emails and my LinkedIn on my GitHub. I will push this code to GitHub. You can download it here and learn it. Okay. So these kind of projects are very helpful. If you put it in your resume, you can increase the weightage of your resume in job hunting. So I think that's all from my side. I will be logging off. Thank you. Have a nice day. Have a nice weekend.